The planet's widely recognized as having one of the best networks in the industry, but we never have the opportunity to really explain what the network looks like from the inside and what makes it the best. What keeps the reliability up, what keeps the scalability up, what keeps the capacity up. So I wanted to take a moment to, diagram out what the network looks like in our perspective and how it's growing and how it's improving. So you'll see two main hubs. You'll see the Houston hub and the Dallas hub separated by a couple of 100 miles. And each one of the hubs itself has its own interconnectedness and it has its own bandwidth drop. This is mainly because, if we have all the connectivity in Dallas, then we're relying on kind of an intercity connection to feed our Houston data centers, and vice versa if that were the case. You'd see some latency in the other data centers in the other cities. So you'll see, each one of these black boxes is representing a facility, either in Dallas or in Houston. Our main data centers being D4, D2, D5 and D6 in Dallas, and then H1 and H2 here in Houston. In Dallas, we also have a facility that's mainly a network hub, and in Houston, we have our Houston headquarters down here in downtown. But I guess I can start with Dallas first and explain how the data centers themselves are connected, and then we can kind of branch out and see where the bandwidth's coming from and how the cities work together. So each one of the data centers in Dallas, or each one of the facilities in Dallas, I should say, are connected by a redundant dark fiber loop. So I guess I should touch base on what redundant is all about. That essentially means that any one of these connections can be taken out and you don't see any loss of performance or any downtime in any of the other facilities or any facilities at all. So that means that we can cut this this connection out and D5 can still get to D4 pretty easily. It's not going to look exactly like this. This is kind of a representation. These are going to kind of interconnect different ways, but it gives you a good idea of how they all work together to essentially form one cohesive unit. In Houston, we have a similar setup where H1 and H2 have redundant connections between each other, so that if one of them goes out, then the other one can pick up the load and share bandwidth and have kind of inter-data center bandwidth and speed that would otherwise have to go through the internet as a whole. And then we also have a connection from H2 to HQ. And so as we kind of build this out, HQ is our new office that you've seen in earlier blog posts. As we build this out, HQ is going to have a connection to H1 as well, which essentially completes a circuit, if you want to think about it like that, of kind of connectivity and adds a whole additional layer of redundancy to H1. And it even adds redundancy to HQ. If for any reason H2 can't communicate through H1 via the two interconnects that we have currently, it can route around through HQ and nobody loses any kind of performance at all. So you can see, I guess, obviously that each one of the hubs is redundant, and each one of the individual data centers has redundant network hardware and stuff like that. But you can see that the connections are going to be redundant, and it's also going to kind of be redundant in between the two cities. Let me first explain where the bandwidth is coming from and what kind of bandwidth we're talking about. So we have roughly 120 gigabits per second of bandwidth capacity, and most of that's coming from tier 1 bandwidth providers like NTT and AT&T, Global Crossing, and Level 3. But in addition to that, we have some peering relationships in Dallas, and ultimately, as you'll see, it's not going to really matter where they're coming from. It's all going to, I guess, touch this one cohesive unit, and it's going to improve the network performance for the rest of them. So when we're looking at the 120 gigabits per second of kind of tier 1 bandwidth, about half of it is coming into Houston in two different places. So about 60 gigabits per second is coming into Houston, and about half of that's coming into H1, and about half of that's coming into H2. That means that if for any reason the connectivity is lost to H2, through the interconnects, H2 can take H1's bandwidth and vice versa. And it also allows us to kind of engineer the bandwidth around to provide the best performance to each one of the data centers if needed. Now Dallas is set up a little bit differently. It's roughly 60 gigabits per second of tier 1 bandwidth. It's all coming through this D3 network hub location. So instead of having it in each one of the data centers, we're going through network hub kind of station where the network hardware is redundant and things like that, and it's shipping it to different redundant hardware in the data centers themselves. But D3 is acting as the main hub, distributing the bandwidth to the dark fiber redundant ring. And that's a little bit more than 60 gigabits per second. This one's a little bit less than 60 gigabits per second. But as they work together, you'll see that ultimately the entire network essentially has 120 gigabits per second of connectivity at its disposal at any time. And that is mainly because we start to figure in the intra-city connects. So H2 connecting to D3 allows for H2 to take some of D3's bandwidth if necessary. And that's kind of like a worst case scenario kind of situation, but that's important for redundancy and important for network cohesion. So if by some chance entire H1 and H2 bandwidth for any reason would slow down or just need additional bandwidth, we can pipe that down from Dallas over an interconnect, and then we're also building out an additional interconnect from H1 to H3 to provide a similar kind of feature. And you'll see that, I guess, as the network as a whole kind of takes shape and forms, that it becomes one kind of big circuit where there's always a different path for something to take to get to a different data center, and it's always available. I guess a path is always available to share bandwidth if that's at all necessary. With this kind of circuit path and with the circuit structure, it also allows us to scale a lot better, because these peering relationships or this bandwidth drop in Dallas can be enlarged, or we can add network drops here in Houston at H1 or H2, and that bandwidth essentially is available to the entire network relatively seamlessly based on the connections between Houston and Dallas and the connections between each one of the data centers themselves. So this also, I guess, with the complete circuit, helps out with the redundancy, because even if, like I mentioned, if something goes down anywhere, some that bandwidth is going to be available so that you'll never see any downtime due to a network failure. So I think this does a pretty good job of explaining what the overarching network looks like. But if you have any more questions, you're more than welcome to leave a comment here on the blog, or you can send me an email, khazard@theplanet.com, and I'd be happy to either answer your question or get an answer to your question. But overall, this is what the Planet's network looks like to provide the most uptime, the most reliability, the most capacity of anybody in the industry.